Yeah.
Next up is our guest presenter. I'm really thrilled to have Anna Paltseva with Purdue University, an international urban soil scientist, joining us to present her work on soil contamination. Thank you, Anna.
Thank you so much for having me. It's such an exciting group of professionals, and I'm excited to live now in Midwest. And today I will take you on a little journey of my research, and you will see where I have been traveling to, and you might wonder where this accent is from. Okay, I hope you can see my presentation. Yes.
I see it. It is still in editor mode right now.
I share. Hold on. How about now? I quick slides now. You don't see it?
It didn't change for me yet.
It is weird.
Oh, wait. Someone else says it's okay.
Let me. I'll just redo it just to make sure.
Yep, let's try again. Thank you.
Oh my gosh, this new thing. Stop sharing.
Yep, we all get familiar with Zoom one way and then it changes.
It was fine this morning, so we practiced.
I'll just close my presentations and reopen them again.
Good, we'll try.
Okay, I'm sharing now and I'm clicking the slides.
That looks good. Yes.
Okay, awesome. Good. So welcome to my presentation, Is Urban Gardening Hazardous to Your Health? I know it sounds a little scary, but I promise we will get to solutions and see that growing food, even spoiler alert, in contaminated soil can be fine. So where I come from, I'm originally from Russia. I grew up in the south part of Russia where we have a lot of agriculture fields. It's actually very much similar to Indiana, maybe a little hill there. But my parents are professional agronomists, and my father was a manager for a very long time on a collective farm. And now we have our own farmland where we grow mostly wheat. But my parents also grain for the grains and some peas. But my parents also have a big garden where from early years they taught me how to take care of our own land, how to care of our surroundings and grow our own vegetables. So little did I know that 20 years later I would be doing this work in a professional scale at the College of Agriculture in the Midwest. And I first came to New York City when I was my early 20s to pursue my degrees. I received my PhD in CUNY, City University of New York, a graduate center, and did a research at Brooklyn College. That is one of the first and one of very few urban soil labs in the US. After I received my PhD, I spent 4 years in another Lafayette, Louisiana, where I was an assistant professor in the School of Geosciences because my background is in earth and environmental sciences, and I did my research in contamination of urban soil. So I have a kind of diverse background. And just last year in August, I joined Purdue as a clinical assistant professor. I'm working on establishing urban soil program here and I live in Indianapolis, so I will be in between two places because we're also developing campus here in Indianapolis, and I hope to see more programs and more research done in the city as well. So in today's presentation, I will share with you what I've done so far, and hopefully it will spark some questions and discussions. When I originally came to New York, I was quite surprised to see these gorgeous gardens around the city where people would grow food like zucchini and collards and potatoes and tomatoes. I was like, why do people grow food in New York City? I grew up in '90s and like in Russia, everyone grows their own food. Back then, there were like no stores where you can buy, or stores were there, but no food you can like tomatoes or cucumbers you can buy over winter. So fresh produce was not available like nowadays. So we had to grow our own vegetables and preserve them over the winter. But like in New York, there's big hub in transportation. Like you can buy anything. And I learned later on when I joined Brooklyn College Lab that urban gardening provides more than just nutritious food. So and this is why it's so important to have more gardens and urban agriculture, because of course it provides healthy nutritious food. It helps with the grocery bill reduction, but also helps with the health benefits, because people, especially it was found during COVID, where people spend more time in the gardens to minimize the mental health capture. It was challenging for us to be in the small apartments. So we find some good retrieve when we spend at least a few hours a week in gardens. So it really has great mental and physical health benefits. It also research found that it minimizes criminal activities. It's less likely that people would hurt each other if they work in the same garden. And and also it connects people to agriculture and nature. But there are some common contaminants and some toxic pesticide residues that we can find in soil, in addition to some pH, polycyclic aromatic hydrocarbons, emerging contaminants like PFAS and microplastics. In today's presentation, we will mostly talk about heavy metals, lead in particular, and then I'll touch base a little bit based on some previous feedback and interest in a little bit about pesticides. So, what are the common contaminants? I typically ask these questions of auditorium, but I hope you can answer it in your head. Uh, the most common ones: arsenic, cadmium, chromium, copper, mercury, nickel, zinc, thallium. The list can continue. There are lots of harmful substitutes in our soil, but uh, arsenic and lead is something that I mostly focused in my dissertation. And lead is probably the most infamous and most common element that we find in the soil. Lead comes from historical use of leaded gasoline that was uh, emitted into the air and then accumulated in the soil. Even though it was banned in 1978, the legacy of contamination from gasoline and lead paint from like walls, from a roof, from paint is still present in the soil, because this paint can chip off and redistribute into the environment. Of course, lead can come from pesticides like lead arsenate was a common pesticide used in 20th century. One of the case studies I will talk today, we actually work with this consequences of lead arsenate pesticide in New Jersey. And there's some other contaminants you can see. Well, arsenic we mentioned comes from insecticides, from treated lumber. Cadmium can come from phosphate fertilizers and sludges, industrial emissions, runoffs. Chromium comes as well as copper from treated lumber or timber. A lot of these elements, of course, come from industrial activities and emissions. Some of them, like copper, come from also fungicides, and a lot of metals come from coal combustion. But most of these metals, it's really a legacy contamination that we elements we use since like more or less industrial revolution, and then throughout 20th century we're using it a lot, and some of them were banned, but we still have them in the soil because these metals are not really mobile and they tend to stay in the environment. So why lead is a concern? Lead is neurotoxin. It affects cognitive development of children. It's quite immobile in the soil. It doesn't really like wash away with rain. Arsenic is more mobile and it can leach to the groundwater. But lead mostly stays in the topsoil. It can translocate based on some maybe like flooding or um, tornadoes, like dust storms, something that can physically move soil or dust, but for the most part, it accumulates in the top layers. The layers would be most likely garden. And how do we get this metal from the soil to the human body? There are multiple ways. One, as you can imagine, is through consuming vegetables that are contaminated in metals, because those plants would uptake it or have it from just adhered particles with metals on their surfaces. Then we eat them, and it accumulates through the food chain. Uh, Direct exposure is actually the most common one. And out of this direct exposure, it's mostly ingestion and house dust that is the most prevalent pathway, followed by inhalation, like dust, especially in summer when the season it's more dry. And dermal contact, it will be more for acute exposure. People who work with metals at work, maybe it's in the factories. It could be in a farmland with pesticides, but something where you can get higher exposure at a shorter time. And then the third pathway is leaching to groundwater and the consumption of this groundwater. So it's really for us, it's important to understand how much gets into human body through these different pathways, and especially how much children can ingest soil that is contaminated with lead or other metals when they play in the playground or in the garden, because kids love to lick their fingers, taste everything around them, and it's really important to know what's in our environment. And house dust. This dust can come from like open doors or windows. Window sills might contain old lead paint, and it can slowly chip off as well and then redistribute into the environment. Children are very susceptible to lead exposure, lead poisoning, and for a child to get lead poison is enough to consume this much of lead, like this tiny, tiny bit of our pen. This is a small particle of lead paint would be enough for a child to get lead poisoned. So if any one of you ever traveled to New York City, you've seen this beautiful map, and if we dive in into the geography of this beautiful city, we will find that in this area, northern Brooklyn, close to Manhattan, we when we study soil, we find there's a lot of pollutant sources, like higher traffic areas, Superfund sites, infamous Gowanus Canal is there, a lot of former industrial sites, brownfields, navy yards, smelters, uh, and a lot of people who live there. So we conducted this research at Brooklyn College. We had a lot of samples sent to the lab over multiple years. In this map, we used about 2,000 samples from gardens, mostly from gardens or public areas where people send their samples to us. So it's really an area where people kind of work with soil or maybe engage with soil if it's like in the park and they sit on the lawn. So what we find is inner city of this northern Brooklyn is where we find the highest concentration of lead. And it kind of disperses as we get closer to suburbs or like further from the inner city. And this is a very typical pattern that has been found in cities around the US, and where the older part, the inner part, where it's a high traffic area, older housing, uh, and most likely even vulnerable communities who live there, and potentially can get a higher exposure to metals. So what does this concentration mean? I have the map color coded in different numbers, and 400 parts per million or milligram per kilogram until about a year ago was considered as a guideline for lead in soil of children's playgrounds, bare playgrounds. Last year in January, EPA moved this guideline to about 200 parts per million, so much lowered it. But empirical research, and specifically research done in New Orleans by Howard Milke, who dedicated his entire career to study the blood lead level in children in correlation to soil lead, he found that it should be closer to natural levels in the soil. So we would love to have less than 50 parts per million or milligram per kilogram in soil to prevent lead exposure. So here we can see the colors. Other cities, Indianapolis and Chicago, different colors a little. But if we look at the like 200, it's like orange. Everything that's orange and darker colors, much higher concentrations. This data was collected by Dr. Filippilli from IU, and he's this really great Map My Environment platform that you can look up yourself and potentially find maybe your city. They have cities from different countries as well. So in Indianapolis, we can see, because it's more like a sort of like circular pattern city, we can see very similar thing. It's inner cities that are high in contamination, kind of disperses. We go to suburban, maybe even rural areas. In Chicago, we find again where high population of people, all the parts of the city, a high traffic area would have high concentration of lead in the topsoil. When we zoom in into neighborhoods, this is an example from a New York City Greenpoint neighborhood. This data collected by my colleagues from Columbia University, and they did like kind of zoom in more into what does it look like from property to property. So they use this instrument, X-ray fluorescent analyzer. I will show you how it looks. It's a really cool analyzer, like a big gun that we can use to screen samples in different surfaces. So they collect samples from, you can see like really hundreds of samples in Greenpoint, and they found that public samples, so some of them from like outside of private properties, maybe like lawns and street sides, parks, had lower concentrations of lead compared to private samples, people's backyards. You can see on this pie chart at the bottom. So what does it tell us? That in backyards, people perhaps disturb soil less, like they don't add compost or mulch or don't bring new soil, maybe don't even grow lawn or garden. So this accumulation of metals that just stay the way it is. While in public spaces, they are quite maintained for beautification of the city, and agencies like public park organizations, they maintain at least a lawn or maybe compost, mulch, and over time the composition of soil changes and the concentration of metals drop. It's a really interesting observation. And the soils are very heterogeneous, and they will be different from property to property. They can also be different even within a property. So now we are zooming in into one particular case. It's in Brooklyn, Sterling Community Garden, that in 2014, a little over 10 years ago, was labeled as the garden that gives cancer to people, according to New York Post. So what we did with our team from Brooklyn College, we took our XRF, this gun that I mentioned. It looks like a portable analyzer, which is really cool. Within about a minute, 60 seconds, 90 seconds for better results, we can analyze a whole range, more than 20 elements of mostly heavy elements that found in the soil. So we were able to determine that this garden that looks like this, mostly like it's very schematic map of the plot, actually was not that contaminated as the New York Post was saying. There was some presence of lead in different plots, but the concentrations would differ between plots, but there was no arsenic. And arsenic is actually carcinogen. The only place where we found high concentration of arsenic and lead was next to the road, next to the street. It was fenced area under a couple peach trees that people actually did not use to grow food because it was shaded. And we used this as our case study. So overall, the garden was fine for people to grow the food because you can still grow food even if soil's a little contaminated. We'll talk about that. And we did experiments in this fenced area. We also did experiments in another, I think I took the slide out, but in New Jersey that I mentioned. And in the farm that used to apply lead arsenate pesticides. And we did a kind of similar experiments when we did some phosphate fertilizers to these contaminated sites and composts. We did the different ratios of phosphate fertilizers and different composts and topsoil. We wanted to see what would be the most beneficial for us to use or advise, give advice to gardeners. What would be the easiest and most mm, like helpful way to remediate soil? Something that people don't have to go for PhD in soil chemistry to figure out what to add to the soil to make it less toxic. So what we found is that one is that contamination is not necessarily coming from uptake of plants. Vegetables like carrots, of course, they would have they may accumulate high concentration of lead, arsenic, or other metals in their core. So when you cut off a carrot, you can see the core inside. And that's like a second mechanism for a vegetable. It takes contamination from within, from the soil. It also accumulates it on the surface. So peeling a carrot only partially reduces contamination. But it's different for like radishes or potatoes, maybe onions, something that you can actually peel. And we found that adhesion was it was mostly like adhesion rather than uptake for some vegetables, and for most of leafy greens. What happens is that when a soil particle is attached to surface of a vegetable, if it's a radish grown in the soil, or maybe it's a lettuce or spinach then grown above the soil, but the particles fall on the leaves of the spinach or lettuce due to maybe like dust or irrigation, that the particles just like sprinkle around, or it's just particle soil gets on the surface of leaves, especially short plants. And even though we wash vegetables, we only partially reduce contamination because the adhesion between soil particle and the surface of vegetables or leafy greens or herbs for that matter would be very strong, and it does not easily come off. Some scientists did some lab experiments and even washed the vegetables with nitric acid. It still showed that some particles would still stick on the surface of a plant and it would be impossible to take it off. So washing is important. It reduces contamination, but does not completely washes off. And another finding was here in this case studies that we applied like phosphate amendments. There were like different phosphate fertilizers and composts. So the reason why we added phosphorus, and I'm not saying you should not do it. If you want to figure out the chemistry behind it, like go for it. There are a lot of successful case studies when they use phosphate amendments to stabilize lead. But our target was to find something that would be easier to do for a home gardener or community gardener. So when we apply phosphorus, we combine lead with phosphorus to form paramorphic mineral, which is a very strong form of lead that doesn't easily it's not soluble, doesn't easily dissolve. Even when we consume these particles into like human body, it will just go through us. while other forms of lead could be more soluble, more bioavailable, as we say. And that's why it's really important to understand what kind of form of lead exists in the soil. Looking at its chemistry is also valuable. So the phosphorus amendments, they work, but you need to know how much to add to the garden. So that's why like you need to have some calculations. But what we found was easier way to do is actually composts. When we add compost to the soil, we one dilute concentrations, and two we form organic mineral complexes in the soil. They help soil to form organic mineral complexes that are more stable, and they reduce the concentration of metals, and also just keeping it in like kind of like a chelate, like chelating it in aggregates. So overall, we found that plant types, what we grew in our contaminated sites, were more important than the type of amendment we added. So we found that herbs and root vegetables would have high concentration of metals uh, in the tissue. So root vegetables, they have very weak barriers, physiological barriers in the soil, in the tissue. So metals can get from the soil into the tissue easily. Herbs, they have very large surface area and somewhat like hairy surfaces, so they capture more of particles on their surfaces. And then it's followed by leafy greens. Because they're short, they get splashes from surrounding areas, so it's not really uptake, it's mostly from splashes. And then we found that fruit vegetables could be fine to grow in moderately contaminated soil because one, they have a higher, like a stronger rather barriers, physiological barriers, so that they prevent contamination going from the roots in the fruits. And also because they are further from the surface, they don't get splashes easily on the fruits. So growing something like eggplants and squash, or maybe, or of course tomatoes, something that grow further from the soil would be really beneficial, even if soil has some level of contamination. So how can we fix the problem? What would be like the most practical way we can recommend to gardeners or practitioners to do? It's composting, as I already mentioned, right? So there is another biochar and biosolids. They are great, and you can see them on the market. So this new amendment, relatively new, biochar is essentially a combusted plant residue that is combusted under very high temperature and low oxygen condition, and it preserves carbon, it improves water retention, it helps with the nutrient recycling, and most important, by capturing and sequestering metals as well. Then we have biosolids. It's a processed sewage sludge. And biosolids have a very similar functions on soil as biochar or compost. However, they might be contaminated depending where they're coming from and the processes. So you need to be conscious what comes out of biosolids, and it would be not advised to perhaps put it in the gardens where you grow vegetables. Another thing is to prevent contamination and avoid our, like, or at least minimize exposure when we work in the gardens or spend time outside, is to have some kind of ground cover. It can be a cover like lawn, just green plants. If it's for plots, we should have maybe it can be landscape fabric or mulch around, or compost, to keep splashes away, so to avoid redeposition and redistribution of contaminated particles from the surrounding areas, to keep it to the minimum. When we One of the greatest practices we can also do on contaminated soil is to build a new raised bed. We would build this. It looks really beautiful, right? But this is actually from our study case in Sterling Community Garden. This was the area under those peach trees, and contamination was here quite high. So what we did, we built eventually raised beds here and put a landscape fabric to prevent recontamination between all the contaminated soil and new soil that we brought in, but still it allowed for some water movement. And then we brought new clean soil from elsewhere. So where do we take this clean soil? There are multiple organizations nowadays that can provide clean sediments. So originally, this really interesting program came out more than 10 years ago now. It's a New York City Clean Soil Bank that is now being replicated in other states as well. Essentially, Mayor's Office of Environmental Remediation came up with the idea to collect sediment during excavation, like when construction is happening. Before the sediment would be taken outside. But then scientists calculate, it's like, wait a second, why do we take away this clean, pristine glacier sand sediment away from the city if we can use it within the city to cover contamination? But because it is a sediment, and learning from previous talks today that the life in soil is really important. So how do we introduce this life into this pristine sediment? Is by adding composts, right? So compost, they have multiple effects in the soil. We already said it helps with the remediation of soil, but when we introduce compost, we help with the soil structure because organic matter helps to form aggregates, make soil more stable. It helps with water penetration. It reduces erosion. It really helps to hold soil in place. It introduces microbial activity. It becomes food for microbes. It improves their or enhances their biodiversity, their activity. As a result, we improve nutrient cycle in the soil and suppress pathogens. Compost release nutrients over time that also help us to be, kind of more sustainable. It overall, I like to say, improves immune system of our soil and have a like lasting impact on the soil health over years. The same for mulch. Mulch can be added in the soil in organic or synthetic form, like materials. But if we focus specifically on organic mulch, straws or maybe straw or wood chips, it's really beneficial because it helps to increase moisture retention. It helps to insulate from extreme temperatures. It provides favorable environment for bacteria and fungal growth. It improves their richness and diversity, and it overall enhances microbial activity that again reinforces the cycle, nutrient cycle in the soil, and have improves the soil structure and overall fertility. So this helps for root growth and nutrient availability for many plants. So we really want to have organic matter in the soil, and it helps us to overall maintain soil health as well as remediate contaminants. There are also emerging contaminants in the soil that we can introduce to the soil. There are different agricultural ways. Some of like it's like food scraps. We can add like orange peels or ground coffee or tea, even like some algae. Banana peels, like apple peels, lots of organic matter that we can introduce to our gardens if we maybe at least chop them into smaller pieces so we can compost them, of course, would be the best. But adding more organic matter to the soil really helps to keep the soil more alive, right, full of life, as well as mitigating contamination. However, as we also know that growing produce, growing different plants, especially the plants that we want, may come with the application of pesticides, herbicides, insecticides, fungicides that play different roles. When we introduce them to environment at very high concentrations, it will affect microbial diversity, the activity, the composition, and that will affect overall sequestration of carbon, nutrient cycle, and sustainability of our agriculture. So what pesticides what are the negative sides of pesticides? They can reduce microbial biomass and diversity if too much of them applied. They can affect enzyme production that affects nutrient cycling and metabolism. They can also harm larger soil fauna, including soil engineers like earthworms, that will again affect soil structure and fertility because earthworms really help to structure the soil and they help with fertility by recycling nutrients. How long the pesticide stays in the soil, it depends on environmental factors, on soil composition, pH of the soil, microbial activity, climate. Some pesticides can stay just a few days, some of them can stay several months. For example, a glyphosate half-life goes between 1.5 days to 53 and a half days. There are some herbicides that can persist much longer in the environment that will depend on the chemical properties of soil and the interaction of the herbicides with the soil properties. So here's something that I love to share with our gardeners or people who want to take away easy, actionable steps how to remediate soil. Throughout my research and practice and a lot of community outreach that I've done in New York and Lafayette, Louisiana, I've learned that we really need to learn how to communicate research findings in an easier way. So a lot of time I heard from people that feel very discouraged by the amount of scientific literature that it's available or not available because you have to pay for the article, but then it's how complex it is to understand. And I like to translate science in something more accessible for general public. You can use a QR code to scan the article that talks more in the detail about legacy lead in urban gardens. It's a free open access for you, but overall, this is kind of like a snapshot of what we can do to improve soil health at the same time remediate or mitigate soil contamination. So again, it's adding a lot of organic matter, compost, biosolids, biochar, mulch that promotes aggregate stability, absorb contaminants, improve soil structure, help with the cycle of nutrients, and reduces erosion. If soil is low on pH, then we need to add lime. That at the pH that is close to neutral, lead, arsenic became less available, like the metals. Conservation practices are always way to go, like dust control, and don't put your gardens close to the road. So in Louisiana, I developed a Delta Urban Soils Lab that now is officially closed that offered soil testing for different communities and in Louisiana and beyond. And this lab was focused on environmental stewardship, community engagement, sustainability, science communication. Together with my students, we did a lot of events where we would take science that we research scientific findings that we obtain in the lab and share it with the communities. So we did a lot of these activities during festivals, some kind of a community event specifically for children, so we can engage them in soil science. At the same time, we could talk to parents and ask for their permission to collect their samples and analyze what's in their gardens or their properties. Here's one example of our research in Louisiana. We mapped lead in Lafayette, Louisiana, and what we found was a similar pattern that I showed you in New York or Indianapolis, when inner city center was mostly more contaminated than suburban or like more out neighborhoods, like outside of the city area. And we use X-ray fluorescent analyzer for our studies because we can analyze more samples at much quicker rates. And this result we try to share at the community events with the help of my students. As I mentioned, I love sharing research and I love educating people about urban soil. And last year I published the Urban Soil Guide. It's available with this QR code. You can get a copy. It's a practical resource for anyone who want to either teach soil, urban soil, or uh, do yourself project. It has 20 activities, from how to test soil texture, pH, soil structure, contaminants, and learn how to do it on your own. Really a good resource for workshops, for uh, introductory soil classes, also for activities in the gardens. And if you would like to learn more about soil science, I have a YouTube channel where I digitally preserve lectures, not just mine, but from experts in different aspects of environmental science, agriculture, and soil science. And I will be happy to connect with you on social media. On Instagram, I'm mostly available or run my platforms on Instagram or LinkedIn. So I would love to learn about what you do and open to collaborations, because I'm new to Midwest. I'm still learning who is doing what. So I'm really excited and appreciative for Stephanie to invite me to become part of your community. And I would love to have exchange and open to ideas. So today I'll talk about how soils heterogeneous. We talk that from a city map down to neighborhood scale to gardens, that soils have different properties, especially when it comes to contaminants, and the concentration can be variable within several feet. Urban soil testing is really important, and we need to prioritize it. Remediation options are available. There are multiple amendments we can apply. Organic matter, like compost mulch, would be the most recommended. Raised beds would be great to build uncontaminated soil. And we can choose crops we can grow in contaminated soil if you don't want to do remediation. So here's my contact information, Paltseva at Purdue.edu. Send me your email inquiries, and I'll be happy to take any questions now or whenever uh, we have time for it.
Yeah. Thank you so much, Anna. That was a lot of interesting research and guidance there. I appreciate that.
Thank you.
Yes, we have some time for questions now. There is at least one in the Q&A, so I will pitch that up here. The question says, what are best practices for mitigating areas with elevated levels of lead? What does long-term tracking look like when addressing lead in urban areas? This was posted about midway through your talk, so.
Well, where do you see? I don't see it. I wanted to see.
You go to your little
Chat.
control bar.
Q&A.
Q&A.
Oh, I see. Good.
Yeah.
Thank you. I was looking at the wrong one, just to make sure. Okay, so the loan tracking is a great question. So we amended and we reduce contamination. One, it happens by dilution. Dilution is solution to pollution. And two, it's again creates these organomineral complexes that decrease bioavailability or toxicity of soil, right? Because we create like this chelates with the organic matter, like aggregates that lead is inside of organic matter. But there is really no answer for how long it's going to stay. So over time, we still need to maintain it and add more organic matter to keep this lead intact, because organic matter, as we know, will break down, right, and decompose. So there, as far as I know, there's no answer to how long, what is like long-term remediation. But because we constantly add organic matter, we will it's not just like one time solution. For one time, for like several years, you will be okay. After several years, when organic matter breaks down, probably need to add it again. And by adding it every time, you will reduce it. Or if you don't mix it, you can still bury the layers underneath. So eventually you will build up a new layer of soil while you plant. But our research shows an analysis of other articles that naturally concentrations of lead decreased even without interventions. There were some articles that we compared and analyzed like lead concentrations in cities like in 20th century and like nowadays. And different articles, different time scales, but overall we see this like degradation of lead. So basically nature itself kind of mitigates it, right? Because it's there's so much life, there's so many microbes. So even without intervention, it decreases. But it just will take much longer time if the concentrations are very high. So I would suggest the easiest way is to use organic matter and different forms, as we talked in the presentation, or to build raised beds, and over time maintain it and test it. So find a lab that offers inexpensive tests, something like XRF. If analysis are offered, it would be good because they're inexpensive, like $10-15 per sample, and you only need to do it like once in a few years, unless you do very active remediation. And hopefully, I will have the lab here too that will offer this. I'm working to figuring out the logistics for it.
Good. And then a couple more comments rather than questions in the chat, if you're able to see that, Anna.
Okay.
I have a question also. One of your earlier slides just showed the different heavy metals and all the sources for those. And some things like leaded gasoline, right? It's not being added, but other sources, they are also continuous. What's your guidance if you're working at a urban site with soil? Should people just presume and assume that there's contamination? What guidance do you have about when should you get testing or not?
Yeah, so if they're like in a big city and you know something about the history of land of this neighborhood, you can presume there's contamination. I think it's really important without testing is to know what's the history, right? What is the land history and what is the management was done before. Don't have to pay for that. You can look at the sandboard maps, the old maps, insurance, and see what used to be there. Because nowadays it's a neighborhood, but in 18th and 19th century, it might have been some kind of factory or smelter. So you want to know about this. And maybe it was like a burning site, because you can find a lot of things from the like burning of garbage. So start with that. And if you're like, okay, there are some things that potentially some sources, it was like, okay, it might have contamination. So then you can start working with applying compost. Or if there are some funds available, maybe some programs like some universities offer it for free. Some nonprofit organizations offer for free. It depends where we are. Like in New York, we offered a lot of testing for free. In Lafayette, that was funded by Louisiana Board of Region. We also offered it lead soil testing for free. So there are events where people can bring their samples and just to test it. I would suggest like as soon as better, and it's like one-time investment, and then you know if they're they or not without guessing.
Yep, thank you. And if you are able to see the chat, I think there are, those comments and a few questions. I'll let you look
Yes,
at those
okay. So
and
kids from
respond.
the neighborhood tested last summer. Lead tested at 16. Nothing above 3 is acceptable. Wow. We're working to educate families on what to eat and help abatement lead, and also what to plant to help remove metals from their yard, water filtration, eat those dark. Wow. Yeah, this is high, like 3.5, I think, like the latest guideline. So calcium is good to incorporate into diet for anyone, especially children, because lead and calcium chemically very similar, and our organism, our body, if we don't have enough calcium but lead comes in, we'll think that this is calcium because the chemical is so similar. So to avoid this, we really need to have a good calcium intake and a diverse diet. But there are also some medical interventions to reduce lead in bloodstream, like in the kids' body. So there are alternative to nowadays as well. It's really important to know. So it's good people tested it. Contaminate the fruit above the ground. I always do some kind of barrages because I'm lazy and don't like to weed, but it's good to know that it's important to do so. Yes, good. Said it took 10 years for 3 inches for organic matter to be present. Um, In different climates will have a different decomposition rates, right? Like depending where you are. So yes, like several years, and depends how much, yeah, what type of organic matter it is. Some, can decompose quicker than the others, but that's a good number to have. And to know, this is something I'm very interested in creating. If anyone wants to collaborate, I feel like it's important information that is needed. Yes, absolutely agreed with you, Valentina. Is there a legal responsibility? If you it might be state by state related, but like we never legally obliged, we never reported any results to any organizations. When people send samples to us in the Brooklyn lab or Louisiana lab, we would just send the report back to people, and it's on your discretion what you do with this information. For our mapping or like data analysis, you saw like the maps we do, you can never pinpoint where contamination is. Like we can never say which address it is, and we don't disclose this information. And even when we put in the databases, it's like census tract based or zip code based. So there's always a fear of people to have their, oh gosh, sorry, property value to be decreased, or they have to do something. But from our end, we just report the data and you decide what you do with that. At least like because we work with not organizations but individuals. What about dying trees that have been cut down? Would it contaminate the soil? Well, it depends on the tree. Depends on well, mulch comes from the trees, right? So it's really important to know if the vendor, like what kind of vendors we use, are they trustworthy? We can test them as well. But the content probably it will be unless it's like super hyper accumulator plant, it should be okay because some level of trace elements is fine to have. It's when they go above the guidelines, right? Like metals are in the soil. Geologically, we have we call geogenic minerals like metals that in nature because they're there by nature, but they come from minerals. But it's when they anthropogenically introduced and exceed certain levels, it becomes danger. So it's all about the levels. Lots of calcium and greens and greens. Okay, good. Okay, and then in the chat, no QA. If I'm doing raised bed gardens, what can I do?
Yeah, I think these are from earlier.
Okay, good.
Yep.
So then I replied. Well, but if you have more questions, do feel free to send me an email or a message on LinkedIn or Instagram or something. I'm happy to chat and learn more because it's a group of people I'm sure would love to be involved with and learn from.